going to do a demonstration right now so we can kind of see the product. So Frank, do you want to give me control? So everyone should be seeing my CATIA screen right now.
We can see you fine.
Okay. So what we have up here is a typical aerospace part with FT&A in it. I went ahead and I created an access system right here called Datum A, B, and C. One of the big problems that I see with CATIA V5 versus CATIA V4, and in CATIA V4, a lot of times the OEM would put the local access system in the model. I'm not seeing that near as much in CATIA V5. You do see a datum structure, but there's no access system, and inspectors struggle a lot of times about inspecting a part in aircraft space. The manufacturing guys would like to see it in a local space so the inspectors can tell people, hey, your holes are off in X or Y. I teach a lot of times to put the model into the same coordinate system as the milling machine so you can really work hand in hand with manufacturing. But here you can see in this model that I created an access system at the datum B hole, aligned the datum C hole on datum A surface, and I called it datum A, B, and C. The planner then will work with that access system. So simply what you basically do is you open up a CAT part, you copy it, and you start inspection planner. And we paste the CAT part in a CAT product. So we are working inside a CAT product, and the advantage of that is that now you can start, if you wanted to bring your NC holding fixture in, if you wanted to build clamps, if you wanted to do other things, you could do that inside a product where you can't do that inside a product. So a product is a CATIA assembly. And we're over here on the right side where we says start a new plan, and we'll call this demo. It's prompting us to pick the access system where all of our data is going to be coming from, and it's prompting us to pick an access system that's going to align the probe. So right now I have X-axis going like this, and in our software it's asking us to align how the part is sitting on the CMM so the X is aligned to the positive B axis of your probe. And we have flexibility on aligning the probe to X or Y axis. So that's in the tools option. So we say, okay, so now we have started an inspection plan. This is the edit window showing up here on the top. A lot of times you might be working with a dual monitor, so you can slide this edit window over to another screen, give yourself some more real estate when you're doing that. All of our icons are here on the bottom, and on the right side, we'll start out by putting in a comment, and we'll say inspect holes. So it's very easy to put in comments. So we start building an inspection plan. We have a tolerance button, so we're seeing the FT&A in the model, so we can create the tolerances based on the model. If you are working with an IGES or step file, you would not see this FT&A or this MBD information in the model. So we get to work with that MBD that's in the CATIA model. We want to put a path in so we don't have any collisions, so we can move in and out of the hole. So we're going to put in a move point of 2.5 that leaves one hole and goes into the other hole. And we can also put in approach and retract distance. I'll put in a 30 thousandths because we're working with some small holes. I'll put in a plus or minus 30 thousandths for the approach and retract. And I like to use, we have several ways to create go-to points. This is the fastest, easiest way. We can indicate on a plane. So we get to use all our CATIA capabilities. So right now we created that go-to point at 1 inch because I had a plane there at 1 inch. And you can see the probe right here. We also have the ability to create your different probes under tools options. You can come into inspection, and we have a probe builder right here. So you can create different, your probes. Basically, these are all the dimensions that are on a Renishaw PH9 or PH10 probe. And it's a parametric probe that gets built and is put inside the CAT product. We also have customers that do this for NC 5-axis heads. So we give you the tools to do that, and the V5 Planner doesn't really mind what it is. It puts the model right into the CAT product. We also have a post-processor setting that we can put headers in, we can mirror the program, things like that. So we started out our plan, and we put this go-to move in, and now we want to probe these holes. We have different hole routines down here, like we talked about. We can name the hole. We want to probe it 4 times. We want to go 30 thousandths down. These are going to be PT measure holes. We can do inner or outer. We can do auto measure holes or hour measure. You CATIA or your CMM guys that are in the audience understand all these different ways to measure holes. So we simply just pick the curve, hover over the curve, and we can select the curve. Right now our vectors are going all the wrong way because we want to approach from the top, but I'm going to take care of this all in one pick. So I'm just going to pick all these holes, and I'm going to say reverse them all. So I want to approach a 1/4 inch from here. You can see the green where it's going to probe the hole, and then I'm going to say OK. So we created all that data. We can also turn the name of the probe holes on. We kind of talked about that a little bit with MVD in our presentation. I think it's very important to create roadmaps where the engineer or the customer gets to see where your stuff is taken from. So we create these unique names and labels in the CATIA model that you can turn off and on. We also do create the information in the CATIA tree. So all this information is being stored in the CAT part. And like Frank said, our program is associated to the CATIA model. So if the CATIA model gets updated and these holes change, this information gets updated because our CMM program is associated to the CATIA model. So you can see it's very easy to probe holes. If we wanted to probe this face over here, we can do another go-to move. So let's say that I wanted to lift up to here, and I wanted to move the probe over to here. We can move the probe like that. If I wanted to change the angle to that face, I can just simply pick this icon, pick that, indicate, and it gives me what the probe angle is in that face, so I can change it. And you can see the probe change to that face. So it doesn't have to be a flat face. We can pick a contoured surface or a flat surface. Wherever we indicate, it aligns the probe to the nearest 7.5 degrees. In our settings, as probes get to be more like 1 degree or whatever, we have the ability to say what you want to round it out to. Right now it's defaulting to 7.5 degrees. If I want to put a grid of points on this surface, I can simply pick, these are all of our surface, different ways to create surface points. I can pick this and I can call this upper flange. I can put upper flange. I can put a 1/2 inch grid by a 0.1 grid, and I want to say I want to stay away from the edges by 50 thousandths. I can set the color of what the points want to be. I can set the appearance of what my points want to be. I simply pick the surface. I want to approach it from here, and it's asking me now where is my 1/2 inch direction from, and where is my 100 thousandths dimension from. You do a preview just like you can in CATIA, and you can say, well, that's a lot of points. Let's not do that big a grid. Let's do maybe a 0.2 grid. So you can do the same thing, pick that, reverse the vector. Say I want to go from here to here. I want to keep it within 50 thousandths. Preview. That looks much better. and I say accept. So very, very fast way to lay down points. All those points are named upper flange, so we can turn on the name. Like we talked about, if we want to make a roadmap, okay. All that information then is also being stored, like we talked about, up right here, upper flange. Those points are in our CAT part, okay. There's OEMs that call these things different things. Northrop calls it Quade. Sikorsky calls it drive to point. So we basically are doing the same thing, putting in the CATIA model. If we want to program some other ways to create points, we can come in and we can do some other neat things. We can say, let's do a go-to move over here. Let's align the probe. We could just key in the probe angle if we knew it with this pull-down box, but I really don't know what my angle should be, so I'm going to pick that surface again. And you can override this. Let's say I don't want to do a 90 degree, I want to do a 45 degree. Okay? I like to always come back to where I came from, so that we leave that go-to point there so we can go back to that go-to point. And now on this particular model, I used to do a lot of work on turbine blades where you had to cut the blade at certain sections. So if you create planes in your CATIA model, we can probe the part at those planes. So we could come in here and say, I want to cut, so I'm going to call this section 1. I want to make 10 points on this contour, and I want to cut it at this section right here and say preview. There's our points, and we'll say accept. And what happens is those points are right at X 4 inches. Okay? Then I could say I want to do that again. We're going to name this one section 2. And I want to take that surface. I want to cut it at this. Preview program. Now, those points are at X 7 inches. So you can see that if you have engineering requirements where you want to cut your, to inspect a spar, a turbine blade, anything like that, you have full capability of doing that. Let's say that we want to inspect this part on, along the edge. We'll go back and we'll do another go-to move. Okay? We'll come in here and we'll go back to a 0-0 probe. We'll come over here and we'll say we want to move the probe over to here. And we want to measure along the edge of this part. We could come in here and we can say we want to measure, we want to take 5 points. We're going to call this the edge. And we want to measure that surface. We want to come down from that edge, and we want to come down 20 thousandths in preview. So it gives us a picture of what we want to do, and we'll say program. Now we want to come in here. Typically on a radius surface, the inspector is going to take at least 3 points. So we'll say this changes to 3. We want to come from here. We want to preview. We can flip the direction of where it's going to go. So I want to keep on going that way. We'll say program. So you can kind of see that we can take data really easy around the part, real fast. Let's say that there was some specific points that were put inside the model that you had to inspect, like we were talking about, the Sikorsky calls drive-to points. In this case, we have some KC points that were put in here that were on this flange right here. We could come in here and say we want to measure these points. We want to retain the CATIA name, okay, or we can make our own name, but we want to keep the same name of this. We want to pick that surface, and we want to pick these 3 points. And we'll say done. So what we just did right there is we measured KC1, KC2, and KC3. Again, like we've shown, we can turn on the names and see that. If you just want to indicate points, what a lot of inspectors like to do, they just like to basically indicate, we can do a pick point. We can literally just pick the surface, and we can say, put a point there, put a point there, put a point there, so we can indicate points like this. So we can indicate points. So it's a lot of different ways to do points. This is our 5-axis holes. Right now what I demonstrated was 2D holes that were on a flat surface. If they're 5-axis holes that are going through a contour, you would use this icon. If it's like the old E4 days where the OEM gave you a point and a line, we have a pilot hole. This icon just prompts you to pick a point and a line. So when we're all done, we're happy with our program, we're all done, and we want to simulate the program, we can pick this icon. We want to simulate PC Demas. We'll play at about this speed. We basically say load player, very similar to CATIA NC, and we can say play. And what we're seeing here is we're seeing the probe path following. It's probing down in the hole, the distance we said, and our 1/4-inch move to point is up there, so we don't have to worry about a crash. Now it's probing that surface. So we have full simulation of our program that you can play. When you're happy with your simulation of your program, it's time to post out, and we can post to virtually any CMM, and the posting is constantly being upgraded. If a new language comes out or whatever, we want to generate an app source file for like a Vericut or third-party application. We also want to create the inspection plan. So we want to be able to post out. We pick what we want. We browse. Let's go to a directory. And we'll call it demo1.demas. Save. We sent the post. So we'll go back to there. So what we created right now is we created an inspection plan. This is the coordinate system you guys are all aware of when you work with CATIA. That's where we're working from a local system. This is where it's coming from aircraft space. We put our common in here, our tolerances, some of this information up here. Here's our whole information, X, Y, Z, I, J, K, how many times we're going to probe it, what the size of these holes are. There were 125 holes. And so I call this the plan. It's very easy to read. It's probably easier to read than Demas data. Okay. We also create an app source file. This file would be ready to go into I think I got repeated names here. Let's post that again. Oh, I never picked. I see what I did. Sorry about that. I never put PC Demas. So browse demo2.demas. So again, there's our plan that we just talked about. This is our app source data. So this data would go into Vericut or NC process in CATIA. And you already have the probe and you have the model, so you could run the collision detection in NC process. And then we create your Demas code. Your Demas code is up here. I had the header turned on where I was going to do alignment, where I was going to measure the plane, datum A plane, datum B plane, or circle, datum C circle, and do alignment. But here's the start of our program. it put the probe angles in here that PCDMIS needs to know when you bring this into PCDMIS. It also put our tolerance information that we wanted to have right here. It put some of our strategy about moving the hole around. It put the comment that we wanted, and here's our hole information for PCDMIS. It also did that 1/4 inch go-to move, and it dropped into the hole, it measured the hole, it output the true position of the hole, and then it lifted and moved over to the next hole. So that's a whole strategy of how we're going to move it around. And then we got into all our other points and stuff that we use too. It's literally, guys, that easy to use the V5 CMM Planner. Well, at this point, Frank, let's put it back and see if there's any questions.
Okay, thanks, Larry. So let's go here, show that. Okay. So let's kind of wrap things up, and as Larry said, this will be a good time for Q&A session coming up momentarily. If you have any questions that you'd like to present to Larry during the webinar, please type that into the chat window in the upper right-hand side of your screen. And again, those questions will show up here. I've got a couple of them that have come through during the presentation thus far, so we'll hit those with Larry here in a minute. But if you have any questions, now is a good time to get those entered, and we'll make sure that we address those here momentarily. So to kind of wrap up things a little bit, we talked at the beginning about the takeaways. So managing data translation is always an issue for people. You know, revisions of data. I provided a version of the model to the inspection group, and that, oops, something changed. Did I remember to get the updated model to them? So the benefit is that if I'm running programming in the CAD native environment as well, it eliminates that whole translation process, and I'm sure that I'm running on the master model, and I've got a current revision of the model as well. Next, having access to model-based definition. So I assume everybody on the call has had some experience in dealing with receiving models from your customers where there are no 2D drawings. So the ability to be able to program those models offline without the need to create 2D inspection drawings is of interest and value to a lot of organizations. So this solution allows you to do that since you're working in CATIA V5, and you can also see the model-based definition, which eliminates the need for extra drawings to highlight the MBD information. Next, we talked about, you know, many times, depending on who your customer is, if you've taken geometry out of the native CAD tool and you've run it through an IGES or step translation process, there's an extra step in the process to validate the quality of the translation. And by virtue of using the solution that we presented to you today, we eliminated that extra step in the process. So it certainly saves time and potentially saves the need to license additional software and pay the ongoing maintenance on the validation software as well. And then since this solution runs on your current CMM hardware, there's no need to upgrade your controller. There's no other need for any CMM retrofits. In fact, to the CMM operator, this looks like any other CMM program that he or she would have created the way that you're doing it today. And so it's just a matter of load the program and run the program. So there's no need to retrain the CMM operator.